previous video, we have learned about the basic concept of artificial neural network, what is it based upon, and how does it work. So in this video, we'll try to understand about simple neural networks which are based upon very simple concepts. So what are the different classifications of networks that we'll be discussing in this video? Single layer feed forward neural network, multi-layer feed-forward neural network, multi-layer perceptron, and feed-forward backpropagation neural network. So, the first one, single-layer feed-forward neural network. As the name itself tells you, this neural network has only one layer, as you can see in the image here. It has input and output. This is one of the simplest forms of neural network which anyone can build. So, as I've mentioned, it's a single layer neural network. It does not have any hidden layers, as we have seen in the previous video about the basic architecture of a neural network. So how does this neural network work? So in this neural network, so basically the outputs or the output data sets you get after the output neurons is based upon the weights which are assigned to the input data sets. So let's see in a brief how this one works. Let's assume you are giving some input data. In this case, we will assume its precipitation. You are trying to understand its pattern to say tomorrow's precipitation. So you will give the network both input and output to train the network, and then after you have given the input here and it has understood what the output it needs, it assigns some weights to the inputs and thereby converting the input value, let's assume it's 10 from your observation and you of the data and your output to be 20. So it tries to convert 10 to 20 in this weights layer and tries to predict it to the best possible. So that's what a single layer feed forward neural network does. So the next model being multi-layer feed forward neural network. Again, as the name says, this has multi-layers, more than one layer. In this layer, in this neural network, there'll be a hidden layer. So, in the same way as the single layer neural network works, it takes the input, then sends it to the hidden layers where again the weights are assigned. Then again, these weights are converted to the output dataset what we want. It takes two steps instead of one step as in the single layer neural network and tries to predict the output. So due to the introduction of this hidden layer and extra computational capacity, this multi-layer feed-forward neural network is computationally better than the single layer feed-forward neural network. Similar to the approach followed by any basic neural network, it uses the weights to convert the inputs to the desired outputs. And unlike single layer feed-forward neural network where it has only single layer, this neural network is capable of performing more complex operations due to introduction of a hidden layer and multiple weight assigning during the process of developing a model. So the next one being multi-layer perceptron neural network. Again, as the name states, in this neural network, unlike the previous versions of multi-layer feed-forward neural network, there are multiple layers of hidden layers which can be more than 2, 3 or so on to understand the basic mechanism going on inside the system which are assigning and try to predict it using the number of layers in it. So the functioning of any neural network is similar. The input layer gives the data set to the hidden layers where the weights are assigned. As the steps pass on, different weights are assigned based upon the input and the output required, and then outputs are obtained. So this type of neural network is more suitable for non-linear datasets where the changes are not easy to understand for a simple layer neural network, like a single layer feed forward neural network. Hence, these datasets which are having non-linear patterns can be analyzed better using multi-layer perceptron. In this multi-layer perceptron model, there is a term named activation function which governs the whole mechanism about how accurate or how fast or how good a model can be predicted based upon this non-linear activation function. For now, let's leave this activation function like this, which I'll be dealing further in the next videos. So let's move to the next model. As you have previously seen, all the models, if you have seen in the previous models, all the models travel only one way, that is from only in one direction, trying to give the input to the weights and then to the output. Whereas in the feed forward back propagation neural network, it has a component of back propagation. As you see in the images, the input layer travels in this manner as you seen in the previous models, whereas here there is an introduction of back propagation. So this model combines both feed forward and feedback neural network. The general working of a neural network is same as multi-layer feed forward neural network. The general functioning remains the same, but in this error back propagation is introduced. What do you mean by error back propagation? As I mentioned earlier, to train a model, you'll give both inputs and outputs to the datasets. In the previous models, it takes the inputs and tries to convert to the outputs and just gives it to us without trying to compare and improve the model. In this feed forward back propagation neural network, the inputs are taken in, the weights are assigned, and to the output layers there are various weights given to the inputs and you get output data set. So what the FFBP neural network does is it checks the neural network in itself based upon various parameters which we have given, like number of fails, the number of runs which it should take, and the number, what is the slope between the observed data and the prediction which the neural network has done, and based on that it calculates the errors. So based on this errors, it sends back the result to the weight network, to the hidden layers back towards the front, and assigns different weights to them again and tries to develop a new mechanism again to a better output. This mechanism runs until all the accuracy, the desired accuracy which we have pointed out in the network is achieved. So these are the four basic neural networks which are very easy to understand, and I hope you are able to get a brief view of these simple networks. And in the next video we will try to develop these networks in MATLAB using an inbuilt command, and in the further videos we will try to develop a code based upon that. I will also be trying to use actual data instead of random data to be able to show you the better performance of these models. I hope you liked it. If you like it, please subscribe and share it for anyone you think this information would be quite useful.